Welcome to our lesson on approximation. This is our second lesson, and we are continuing from where we ended. We are looking at the two main concepts of approximation, which are rounding off and standard form or scientific notation. So looking at the first concept of rounding off, we have said that we can round off a number with respect to four different principles or criteria of rounding off. The first one is knowing the number of significant figures that a particular number has. So we can round off a given number with respect to a number of significant figures. So in our previous lesson, we looked at what significant figures are and how we can determine the number of significant figures in whole numbers and in decimal numbers. So we can pick it up from there so that we continue to look at how we can round off a number with respect to decimal places, or understanding what decimal places are when it comes to rounding off. So we have said that the word decimal simply means we are dealing with base 10, which is the normal base that we use on a day-to-day basis in our measurements. So when we say we want to determine the number of decimal places in a number, we are most likely referring to a whole number which has a decimal point. So we call that a decimal number. And so the number of digits that come after the decimal point, those are the ones that we call decimal places. All right. So when we have a number like 2.0341, this is our decimal point. When we are in base 10, we call this the decimal point, which is the base that we use on a regular basis, like I've mentioned. But if we are in a different number bases or different number systems, this point may have a different name. For example, if we're in base 2, we'll call this a binary point. So this is a decimal point because we are in the normal counting system, which is the decimal number system. So the digits that follow the decimal point are called the decimal places, right? So we have after the decimal point, we have a 0, we have 3, we have 1, we have 4 and 1. All right. So it means this particular number has 4 decimal places. This particular number has 4 decimal places. So we can round off a number with respect to number of decimal places if that particular number has a decimal point. All right. So when we talk about decimal places, just know that we are looking at how many digits are following the decimal point. So we are not really interested in the numbers which comprise the whole number part, which are the units that come to the left of the decimal point. But we are looking at the units that come to the right of the decimal point. Okay, so if we have a number like this one, 0.0013847, then we'll say this particular number has 1, 2, 3, 4, 5, 6, 7 decimal places. So this one has 7 decimal places. Okay, and as maybe the last example, if we have a whole number 753, 0.15. Okay, how many decimal places do we have in this number? So here again we'll ignore the units on the whole number part and count the numbers to the right of the decimal point, which means this number is it has 2 decimal places. Okay, so those are the decimal places in a decimal number. So when we want to round off, we'll say, okay, round off this particular number to maybe 2 decimal places. So you know what we are counting. It means we are counting the numbers that will follow the decimal point, starting from the immediate number after the decimal point, that is the first decimal place. So this is the first decimal place, this is the second decimal place. In this number here, 0.001387, the first decimal place is the 0 followed by the other 0 is in the second decimal place. The 1 is in third decimal place. The 3 is fourth position, so it's decimal place number 4. 8 is number 5, 4 is number 6, and 7 is number 7. So that is how we count the number of decimal places. We always start from the decimal point going to the right. Then we have place values. We can also round off a number with respect to place values. We can round off a number with respect to place values. Now again, we'll refer to the decimal number system, or base 10, where you remember we looked at the place values in base 10 at the primary school level. We had an aid such as the abacus, for example, that would help us to understand the place values of a number. Okay, so a construction like this is not very difficult to understand. Now, for example, if we have our decimal point here for a decimal number, we know the immediate next place value to the left of the decimal point is called the ones, followed by the tens, followed by the hundreds, followed by the thousands, followed by the 10,000s, and so on and so forth. Okay, the 10,000s, that is followed by the 100,000s, and these place values continue infinitely to the left. Then to the right of the decimal point, we also have place values that extend infinitely, starting from the 10th. Okay, the 10th, then we have the hundredths, then we have the thousands, and so on and so forth. This one also extends infinitely. It extends infinitely. Now, we need to understand the meaning of these place values. The ones under base 10 is simply 10 to the power 0. Remember, according to indices, any quantity that is raised to power 0 is the same as 1. That's why we call it ones. Then the next place value is 10 power 1, and because the power is 1, that's why we call these tens. The next one is 10 power 2, or 10 squared, and you know 10 squared is 100. That's why we call this place value 100, and so on and so forth. The next one is 10 power 3, which is 10 times 10 times 10, which is 1000. So this place value is thousands. So you should know what the meaning of the place values is. To the right of the decimal point, this is a tenth, and a tenth simply means 1 over 10. That is a tenth. That's the name of the fraction 1 over 10 in words. It's actually 1/10 or a tenth. And the tenth, according to indices, is the same as 10 to the power negative 1. And this is again according to index notation. It means if the power is negative 1, we can write that as a fraction 1 over 10. So when we say this place value after the decimal point is tenth, it means it's actually under 10 to the power negative 1. The hundredth, it simply means 1 over 100, which is 10 to the power negative 2. The thousandth, which means 10 to the power negative 3, or 1 over 1000, and so on and so forth. So this one also continues infinitely as the number gets smaller and smaller. So these are the place values that we have if we are in base 10. So if we're given a number, let's say 18623, and we say let's round it off to the nearest hundreds. Okay, if we want to round off to the nearest hundreds, it means we are looking for the place value for hundreds in this particular number. So we know, because this is a whole number, this place value is ones, the 3 is under ones, the 2 is under tens, and the 6 is under hundreds. So if we want to round it off to the nearest hundreds, it means we'll be looking for the digit 6. We want to express this number with the relevance at the place value of 6, which is the hundreds. So that is how we identify the position of the number that we want to retain as a significant figure, or the number that we want to retain as the accurate value of a particular measurement. So, like we have said, we can round off with respect to decimal places or with respect to place values. We haven't started the actual process of rounding off yet. We want to understand what we mean by decimal places, what we mean by significant figures, what we mean by place values, and then lastly what we mean by units of measurement. Okay, so what do we mean by unit of measurement? Unit of measurement, we know that we have measures of different quantities in the physical world. We can measure distance, we can measure time, we can measure weight or mass, we can measure speed, and so on and so forth. So what we mean by unit of measurement is the unit that is set in a particular value of a number. So for example, if we say this is we have measured a particular length, for example distance. Okay, we measure a particular length and we find maybe 238 meters. Okay, we can measure and find 238 meters. So it means this one is a measurement in meters. But meters is not the only unit of measurement for length. We have also centimeters, and we also have kilometers, for example. We have millimeters. So we can request that this unit of measurement be changed to a different form or to a different value. Okay, or for example, we say we are measuring and we have found 57 centimeters. Then we say we round it off to the nearest meter. Okay, we round this number off to the nearest meter. So that would mean we want to express this 57 centimeters in terms of meters to the nearest accurate value. Okay, so we can, for example, count maybe 47 seconds. Maybe we are counting time and we say we have 47 seconds. So we can require that we round off 47 seconds maybe to the nearest minute or to the nearest 10 seconds. So all those, it means we are trying to find the simplest way that we can round off the simplest way that we can estimate or approximate our unit of measurement of time. Right? So in our next lesson, we're now going into the actual process of rounding off with respect to these 4 qualifying criteria. The first one is rounding off with respect to significant figures. We're going to look at how we do that. Then we will follow that with rounding off with respect to the number of decimal places, then rounding off with respect to the number of place values or place values of a given number, and then lastly rounding off with respect to a unit of measurement. So once we have done the actual rounding off, then we'll look at the last part of the lesson, which is writing a number in standard form or scientific notation.